Right, so question part C. Diagram shows sets F and G. Okay, and it's an unusual one. So F is projecting from A to B, and these are just symbols, and then G is bringing it onto these letters here. So find the value of G of F of 3. Well, so you get F of 3 first. So F of 3 is this symbol here, and it's G then, which brings it to W. So the answer there is W. So that's part I of that. And then next bit is the fiddly one. So it's this injective and surjective. So explain why G, B to C is injective but not surjective. Okay, and you're kind of giving a hint there because you're saying it is one to one but not onto. Okay, so surjective. So it is injective. So it's injective because so a function has a discrete value for each value here in the x domain. So it puts it over to a unique value. Then it is injective. So B from C, G from B to C is injective because it's one to one. Every value of C that is going back has a unique, it's one to one in a relationship back here. It doesn't have to, injective doesn't have the requirement that every value of B has a corresponding value of A in here. But if there is one, that it's one to one, and it's clear. There's no kind of crossing paths here. Everyone is one to one. So that is injective. Now, but not surjective. So surjective would mean that every value in C would have a value back here, and that's not the case. So Y is the proof of that it's not surjective. Now this stuff is, that question I think people would find quite tricky and just pretty fiddly really, and it's kind of more of an English question than anything else. But it does give you, not surjective, it does give you a kind of a hint there, one to one but not onto. Okay, so question 6. F and G are two functions. So f of x is x plus 4. So this looks like a fairly straightforward one. G of x is x squared minus 2. Find two values of x. So this is quite nice. That should be fairly straightforward. So f of x is g of x. So all you have to do there is equate them, and you're probably going to get a quadratic out of that. So x squared minus x, bring that over, minus 6 is 0. Looks like it's going to factorize fairly easily. What's that? Minus 3 plus 2. Okay, with that goes minus 3, yeah. So x is equal to 3 or minus 2. Grand. And that's it. No follow-up question. Okay, the next question is quite different. So find the area of the shaded section. And that's going to region between the graphs from -1 to 2. Okay, so that's quite a nice one. Okay, so, or is it kind of tricky? Let's see. Okay, so it is G, yeah, and X, yeah. Okay, so hopefully probably using the result up here in terms of where they intersect. No, probably won't need that. Anyway, let's have a look. Okay, so something like this. That's -1, better be careful that's not an intersection point. That's 2. Okay, so minus 1. All right, and it's something like this, yeah. Okay. Okay, so that's that's f of x is equal to x plus 4. And you need to get the area underneath there, so it's the area. Okay. All right, so the area underneath the curve. Okay, so we need to get the area underneath the curve there. All right. Okay, so it's this bit here. Okay, so let's get the area underneath the curve. Yeah, all right. From x minus 1 to 2. Okay, so it's the area underneath that and this. Okay, so the area between minus 1 and 2. So getting the area under the curve for x squared minus 2 between minus 1 and plus 2. Have to think about this one. Okay, so it's a third x cubed minus 2x between 2 and minus 1. Third h minus 4 and minus minus 1 minus third plus